Welcome to Maths and Science by IITIAN channel. In today's lecture, I will be taking up rotational motion of rigid bodies. Lecture number 7. Till now, in the last class, we have discussed about the kinetic energy, half I omega W. That's what we have derived. Omega W square is equal to kinetic energy. It is represented by T, capital letter T. Now, we will be talking about, today in this lecture, we will be talking about a body like a spherical ball, spherical metallic ball or a spherical ball rolling down an inclined plane. The inclined plane makes an angle theta with the horizontal. Inclined plane makes an angle theta with the horizontal. Theta, it is better if we can mark like this. This is the angle theta. The inclined plane is making an angle theta with the horizontal. Now, this is the metallic sphere or a sphere rolling down an inclined plane. This is the inclined plane. Physics should always be near to our nature so that you can understand better. Then I thought I took a picture like this, I created an image like this and presented to you so that you will better understand how the forces on a sphere of this type act. Now, the vertical force, gravitational force, always acts towards the center of the earth. Gravitational force always acts towards the center of the earth, so that it is vertically downwards. This is mg. And a normal force always acts perpendicular to the plane on which movement is taking place. This is the inclined plane. Hence, perpendicular to inclined plane, normal force is acting. Normal force. And as the ball is rolling downwards, the frictional force F will be acting always opposite to the motion. Frictional force. And the net force, because ball is rolling with an acceleration, then the net force is acting F is equal to ma in this direction. In the motion of the body, F is acting. Now, we have to resolve this particular mechanics problem and let R be the radius of the sphere and center of the sphere is center of mass Cm. With this background, let us proceed further and try to resolve the forces. And we consider motion without slipping. There is no slippage of the sphere, the ball is rolling. No slippage means the contact between the inclined surface and the ball is always present. This is the contact. No slippage means contact is perfect between the ball and the inclined plane. Now let us move further. I think you might have understood this diagram. This is the contact. This contact is never slipped. There is no slippage. Contact is always present. Ball is rolling this way in this direction. Force is acting in this direction and friction is acting in this direction. Gravitational force is acting in this direction and this is the angle theta. Now, when we try to resolve the forces, what happens? Let us see. Let us change the page to our regular work page. Now we have come to our regular work page. Now, can we draw the free body diagram? Let us try to draw the free body diagram. At the center of the mass, this is mg, the gravitational force, and this is frictional force, because along the plane, this is the direction of motion, and this is the direction where normal force is acting. This is Cm. This is the free body diagram. FBD means free body diagram. Now let us see. This angle is theta because that is the angle of inclination. And the Cm will be rolling, that means Cm will be moving. Let us take the particle as Cm, center of mass as one particle, and it is moving down the plane. You see here, I will show you. The Cm is moving. As body is moving, Cm is moving in this direction. From this place to this place, this place to this place, Cm is moving. It moved from here, here, here. Like this, it will move here, 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 and it will move to down. This is how the center of mass is moving. When center of mass is moving, center of mass moves with a certain acceleration. That acceleration is A. That means this force is equal to ma. Center of mass, A is equal to acceleration of body or center of mass, we can say. When this point is moving in this direction, then in the direction of F, what it is? This is A. And we will take another thing we should not forget, whenever you are doing the analysis of the inclined planes, don't take this as the y and don't take this as the x. Don't do this. Take the inclined plane as x let me take this as x and perpendicular to inclined plane as y. This is the x direction. This is the y direction. This is the y direction perpendicular to inclined plane, and inclined plane is x direction. Take x axis and y axis like this. Do not take regular perpendicular. And rotation, it is a isotropic space, which I have explained you already. In the isotropic space means rotational invariance. Rotational invariance. That means if you rotate the axis, the properties of the particle will not change. Rotational invariance. Hence, either you take the x this way or this way, as long as they are orthogonal to each other, or x this way, there is no problem because of the isotropic space we have assumed. Until and unless provided or mentioned clearly that the space is not isotropic, consider the space as isotropic and also homogeneous. Because these are the spaces where Newton's laws are applicable, Newton's laws of motion. Rotational invariance, translational invariance are applicable. Newton's laws are applicable. That means I can freely, when I change the x and y axis, without disturbing the orthogonality between them and without disturbing the particle, then I can freely resolve the forces. That means my first and foremost thing what I have to do, consider the inclined plane as x-axis and perpendicular to it is as y-axis. This is the first step. Whenever you go for solving the inclined plane problems, first step is to be this one. Next, let us try to resolve the forces in the x direction and y direction. What is my FBD? Please, if it takes time also, if it takes a little bit of hard work also, free body diagram is the most important diagram in solving the physics problems, especially involving forces. Let it be any physics, quantum physics, modern physics, physical chemistry, let it be classical mechanics, anything. Free body diagram. You think of any frame, no problem. Free body diagram is a must. What is the free body diagram? When I consider this as my x-axis, this as my y-axis, x-axis is along the inclined plane. What are my forces? My force, net force towards the direction of motion, that is MA, F. And a force F, this is frictional force, and a force Fn, normal force, and a force perpendicular irrespective whether the object is on the horizontal plane or an inclined plane. The gravitational force always acts in the vertical direction towards the center of the earth, because it is like this. Please understand this. This is r, radius of the earth, and at a height some object is there. This is at a height of h from the surface, or it can be on the surface also. The force will be always towards the center of the earth. Whether the object is here also, the force is always towards the center of the earth. Object is here, no matter where it is, the force is always towards the center of the earth. This is the important concept of gravitational force. Now, this gravitational force is always towards the center of the earth. Earth is like this. Let me make it so that you will understand clearly. Earth is like this. It is not to scale, don't worry. It's only for your understanding. This mg will be acting towards the center of the earth. This distance is also negligible. It can be treated as if it is on the surface of the earth. It's only for your understanding I made it this way. Now, mg is there, f is there. Now let us try to resolve the forces. This angle is theta. Recollect your trigonometry. Here, you are supposed to understand one basic concept clearly. You just see the diagram here. It's a rigid body moving on an inclined plane. The distance of the CM from the inclined plane is, let me say it is y. This is equal to constant because of symmetry of the spherical ball. In the rotational motion and in rigid bodies, we have to consider all the aspects. It's not a particle. Hence, we have to consider the distance between the inclined plane and the center of mass also. As ball is not slipping, it is in contact with the inclined plane continuously. The position of the CM with respect to y axis is not changing. With respect to origin on the y axis is not changing. Let me say this is the origin. This is origin O. The position of center of mass with respect to origin is not changing. But with respect to origin, the position of the center of mass in the x-axis is changing, but in y-axis it is constant. Because if you consider it as a particle does not have dimensions. We need not worry acceleration in the y-axis and acceleration in the x-axis. Whereas here we have to consider acceleration in the x-axis and also y-axis. Now let me clear that point to you here now. This is the origin. With respect to origin, this is the y-axis and this is the x-axis. And with respect to y-axis, let me say acceleration is ay, and with respect to x-axis, the acceleration is ax. Mass is there. This is the CM. Now, take any origin as a reference. The position of the CM, let me say here is the origin O. With respect to origin, I am on a translation. It is a homogeneous space. I can have translation axis. Don't worry about the translation. I am shifting this x axis from here to here. It is not going to make any difference. Y axis is same, perpendicular to this. Let me say this as x dash or x, no problem. We are only analyzing the motion. Now you just see. As far as the y axis distance is concerned, the CM is maintaining the same distance on y axis, constant. But on x axis, CM is here now. After some time CM is here. After some time CM is here. 0.1, 0.2, 0.3, 0.4. After some time CM is here. That means in the x axis there is an acceleration, but in y axis, as y is equal to constant CM position, for CM position, CM is center of mass. That implies d square y by dx square, dt square, is equal to 0. dy by dt is equal to 0. That means velocity is 0 in y direction. Acceleration in y direction is also 0. Ay is 0. Hence, net force in the y direction is m into ay. That is equal to m into 0. That is equal to 0. The net force in the y direction is 0. What is the net force in the x direction? Net force in the x direction is equal to m into ax, which I have written as ma. Because ay is 0, I took acceleration in the y direction only and I have written f is equal to ma. This is the net force in the direction of the motion of the body. This is how you have to understand the concept. Now, with this concept in mind, let us analyze the FBD. It is taking little time, but please bear with me. FBD is very, very important. This is the x-axis. This is the y-axis. Now, there is a force in the x-axis. One is frictional force and vertical force is towards the center of the earth, that is mg, and in the y direction there is one force called normal force F, and this angle is theta. Now you tell me, now you resolve the forces in x direction and y direction. What is Fy? Force in y direction is equal to m into a in y direction, that is equal to m into 0 is equal to 0 is equal to Fn in the positive direction, in y direction Fn is there, and mg is here. Mg, what happens? This mg with an angle of theta here, perpendicular to this is Fn, then this mg becomes, here the component of mg will be mg cos theta. Please understand this. If theta is here, it is cos theta, mg cos theta, because whatever theta is there, the other side perpendicular to that will be mg cos theta, because this angle is 90. This is mg cos theta. Did you understand? If theta is here, here it is mg cos theta. You should not make a mistake here, because inclined plane direction may be changed. The mirror image may be made. In that case also you should be able to understand how to resolve these forces in x and y direction. You should be able to. Then this will be this mg in the x direction, this will be mg sin theta. Mg is this way and this is mg cos theta and this is mg sin theta. Please understand this. Provided this is the angle theta, this is the angle theta. Far away from the theta is mg cos theta, towards the theta is mg sin theta. It is near to the theta, it is far away from the theta. That's all. You can remember this way also. Try to, you make your own mind map and remember this. Now, Fn is in the positive y direction and mg cos theta is in the negative y direction. This is equation 1. Now, Fx is equal to max, that is equal to ma, that is equal to mg sin theta is towards the downwards of the inclined plane in the equation of the motion, mg sin theta minus your frictional force, where F is equal to frictional force. Let us see. I think up to this you have understood. From the above, normal force Fn is equal to mg cos theta and ma is equal to, in the x direction, mg sin theta minus F. Now what is that frictional force? That is the only force which is going to counter the motion of this sphere. For a rotational body, please remember this, for a rotational body, for a rotational motion of rigid body, for a rotational motion of a rigid body, moment of inertia with respect to center of mass into d omega by dt is equal to frictional force into radius of motion. You please remember this, where r is the radius of the sphere, F is the frictional force, omega is the angular velocity, I is the moment of inertia with respect to center of mass. d omega by dt. Can you please tell me another concept I want to develop? R into d omega by dt, which we have already explained in the rotational motion, maybe first lecture or second lecture. R into d omega by dt is equal to acceleration. This also you please remember. Refer to my earlier lectures otherwise. You can see the dimensional. In physics, if you have any doubt, please check the dimensions. What are the left hand side dimensions? I am giving the golden rule to you. Left hand side dimension is R is L, d omega is 1 by t, d omega is nothing but 1 by t, and dt is 1 by t. That is equal to L into t to the power of minus 2. What is acceleration right hand side? L into t to the power of minus 2. Both are same. That means this equation is valid. Are you able to follow me? ICM into dw by dt is equal to frictional force into R. That implies ICM by R into dw by dt is equal to frictional force. I am calling F as frictional force. Don't get confused. Now, you just see. This frictional force I have written like this. What is dw by dt? That is A. R into dw by dt is A. dw by dt is A by R. That implies ICM by R into dw by dt is A by R. Please refer to my earlier lectures if you want further concepts. That means frictional force is equal to, for this particular case, frictional force is equal to ICM by R square into A. But what is our net force? Net force is equal to m into a. But our equation MA is equal to original equation, if you see, MA is equal to mg sin theta minus F. We'll replace F value here. Mg sin theta minus F. That frictional force I will replace here. Mg sin theta minus ICM by R square into A. Do you agree? That implies, what is ultimately equation of motion? Equation of motion is nothing but finding the equation for the motion. That is, equation of motion is nothing but finding the value of acceleration and velocity. Equation of motion nothing but from the force analysis, because F is equal to ma, we have to find out the acceleration. For this body, equation of motion will be, I will bring A here on the other side, ma plus A into ICM by R square is equal to mg sin theta. Do you agree? Which implies A is equal to, sorry, not A, we will write first A into, A will make it common on the left hand side, 1 plus ICM by R square is equal to mg sin theta. Here it is m into 1. That implies A is equal to, ultimately we are interested in the equation of motion, finding the acceleration of the body. A is equal to mg sin theta by m plus ICM by R square. This is the equation. There is one term called as radius of gyration. Radius of gyration is equal to, that I will explain you in the next class in detail. Radius of gyration is the point where the center of mass or the different particle, because it's a symmetry spherical, we have taken center of mass. There may be different particles distributed in different manners in a rigid body, where we cannot get the center of mass moving symmetrically with respect to the other particles. In that case, we take the concentration of the mass at the radius of gyration instead of R. Here we have taken radius, where radius of gyration we will calculate. That radius of gyration, it can be taken as kcm. That is radius of gyration. Then, if radius of gyration is that way, then ICM is equal to m into kcm square, like mr square, which implies we replace this ICM value here with radius of gyration. What happens? Let us see. A is equal to mg sin theta mg sin theta whole divided by m plus m kcm square by r square. M will take it common in the denominator and numerator, we will cancel it. We will cancel m. Then it becomes A is equal to g sin theta by 1 plus kcm square by radius of gyration square by r square. Ultimately, the equation of motion for this particular setup is equation of motion that can be written as EOM, will be for this particular setup like this, where this is theta and a sphere is like this here on the top of the inclined plane, and it is moving with a velocity with an acceleration a, and this is mg. Then the equation of motion is, and there is a frictional resistance is here f. Then the equation of motion is defined by a is equal to acceleration of the body is equal to g sin theta by 1 plus kcm by r whole square. This is the equation of motion. If theta is 0, acceleration will be 0, because the sphere will not, until and unless external force is there, it will not move, that rigid body. And if theta is 90, you can see what it is. Different conditions in JEE Mains and in Physics Olympiad or in CSIR or in NEET Physics, they may ask you, if the angle theta is vertical, what happens? If it is horizontal, what happens? An examiner can ask you. With this, I want to close today's lecture. Best of luck to everybody. Thank you for seeing my lecture. Thank you and best of luck. And you please remember, whatever basic concepts I have explained you, everything is very, very, very important from the point of view of understanding the rigid body motion, rotational motion, and from the understanding of on the point of view of understanding for the examinations like CSIR, examinations like JEE Advanced or JEE NEET Physics, JEE Mains. Once you understand these concepts very clearly and analyzing the components in the x and y axis, and also taking the x axis because of the homogeneous and isotropic space, and translation and rotation of the axis does not make changes for the particle properties, you can move and you can do it without any hindrance. And taking the components in the changed x and y axis, resolving them and finding the equation of motion, ultimately the acceleration of the body. That is the most important aspect of this classical mechanics. It can be useful for quantum mechanics also. It can be useful for your magnetism and electricity also. Please try to understand the concepts of classical mechanics thoroughly, even for rigid body motion. Thank you. Best of luck. With this, I want to close today's lecture. And if you feel there is a value addition because of my lecture to you, please subscribe to my channel, Maths and Science by IITian. And please share and subscribe. For additional knowledge, you please refer to my earlier lectures. Thank you.